Hello students. Today we will be going over 7.1 Solutions to Inequalities. This is page 119 in your yellow packet. All inequalities with solutions have infinite solutions. Okay, our objective, I can solve multi-step inequalities and compound inequalities and give solutions as graphs and intervals. Okay, so remember, graphs look like this. Intervals are ones that will have parentheses at the end or brackets. Remember, parentheses are one that they don't include it, less than or greater than. These include them, so less than or equal to, greater than or equal to, okay? So here, as I said before, all inequalities with solutions have infinite solutions. Like x is less than 2. And so you graph that, it's an open dot at 2. This direction goes all the way to negative infinity. And how many numbers are between 2 and negative infinity? That's correct. There's an infinite number of solutions. So right here, infinitely many solutions. Solutions take the form variable inequality value. So you have 2x is less than or equal to x plus 1. You subtract x from this side and you get x is less than or equal to 1. Any number less than or equal to 1 will make the inequality true. So we have this graph. We're going to put 1 on the number line. And it's going to be open or closed dot with this here. More ink there means more ink here. And it's less than, so we shade all this going down less than. Then we need to write our interval. It goes all the way to negative infinity right here, so it's parentheses. The negative and positive infinities are always parentheses, comma, 1. And it includes 1, and so it's a bracket. And there you have the first one. Next, we're going to go on the second one, all real numbers. Okay, any number will make the inequality true. X is less than or equal to x plus 1. You can subtract x from both sides, and you're left with 0 is less than or equal to 1. So any number can be true. So over here, we're going to shade the entire graph. Anything can be true. So our interval is going to be, goes from negative infinity, and this is parentheses, comma, positive infinity. Okay. Our last one is when there's no solution, no value will make the inequality true. X is greater than x plus 1. Minus x from both sides, 0 is greater than 1. False. So no value can be substituted for x to make the inequality true. So we don't put anything on the graph, we leave it blank, and we also will put empty set, both for the interval and for the number line. Make sure you put a slash through it so I don't think that you think it's 0. So there you have that. Next, we're going to go on to this section, which I have right here. All right. Now we need to graph and give interval for the solution. 10 is less than or equal to 10. Is that true for all values, true for some values, or not true for any values? Okay. So that will be true for all values. Even though our one value is just 10, it's going to be true. So if we substitute anything else in there, it's going to be all, basically all the numbers. So we can just put negative infinity here and infinity here, and we can color the number line because it's all true. And mine isn't very pretty, but that's okay. Okay, so it's all real numbers. And in interval notation, we're going to put parentheses, negative infinity, comma, positive infinity. And again, it's parentheses, not brackets. This next one, negative 7 is greater than negative 2. Well, if we have a number line, negative 7 is down here, negative 2 is here, 0 is here. Is negative 7 greater than negative 2? Is it this way on the number line? And the answer is no. So we put none there. There will be no solutions to that inequality, and we just put empty set for that. Okay. Then our third one, x is less than or equal to -3. That is going to be true for some values. Okay, so when we do our number line, I always like to put 0 there. -3 is going to be here. Does it include it? Yes, because it's got more ink here, so more ink here. And it shaded to the left. Interval notation, it goes from -infinity, comma, to -3. Does it include 3? Yes, so I need a bracket. And there you have that solution. Next, we're going to go on to number 4, where we're going to solve, graph, and then give the interval. So again, we want to treat it like it's an equation. So I put a line here. And you only switch the sign if you divide or multiply by a negative, or you move the variable to the other side. Okay, so I'm just going to solve for n. I'm going to get them all to the same side, so I'm going to -2n, -2n. Make sure when you do it that you put the sign. Some students are not putting the sign, and then they don't subtract, they end up adding. So make sure you put the sign. So 8 over here, and you get 1 minus 7n. Then I'm -1 here, -1 here. I bring this down. Some students also forget to bring that -7 down, that negative sign. It's less than 7. Now I divide by a negative number. Can you guys see that okay? And when I do that, divide by -7, I have got to switch the sign. So I get n is greater than 7 divided by -7 is -1. Then I graph that on my number line. 0, -1. It's an open dot because it's greater than, less ink, and it's shaded to the right. If we wanted to check, we could put 0 back in there because 0 is shaded. So if I put 0 in for n, you get 1 less than 8. Is 1 less than 8? Yes, so I probably shaded the right direction. So again, I just substituted 0, and because it's shaded, it should be a correct answer, which it is. So again, -1, that's not very pretty there. Hopefully you got open dot at -1 shaded to the right. Okay, now I thought I'd do a more difficult problem. On the back side, I'm going to go ahead and do number 13. And again, solve. Oh, I didn't give the interval. I need to give the interval. It starts at -1. It does not include -1. And it goes to positive infinity. Since you can't quite reach infinity, it'll be parentheses. Okay. The next one, back number 13. We have this equation. I put a line down the equal sign. I'm going to combine like terms over here, 9n plus 3. And this is 1 plus 9n. Now I want to get the n's on the same side, so I minus 9n minus 9n. Now I get 1 is less than 3. Now, does that make a true statement or a false statement? That is true. And we do the same thing as we do when we are solving equations and the variable drops out. We see if that's a true statement or a false statement. Since it's true, it'll be infinitely many solutions. So when we graph that, we have our number line. You can put 0 in there. You can put -infinity, positive infinity, and basically shade the whole number line. Okay. Then for our interval, you could go -infinity, comma, positive infinity. So that's all real numbers. Okay, students, you can get the rest of this. You rock.